So, as a professional programmer, I've learned to do a few things. They're just habits, right? One thing is that when you find a problem, when you're working on something, you root cause it. You don't stop and work on the symptoms and just figure out what the symptoms are. You figure out why whatever it was that went wrong, right? Was it bad data? Did you make a bad algorithm? Whatever it is, it's your job to figure that out. And the second thing is that since it's your job to figure it out, you want to make everything as reproducible as possible. You want to put in as much logging as you can. You want to build an environment where what you're doing can be tested without having to have large, complex data, lash ups in place. And there are a number of reasons for that, but the simplest one is that you can test it from your desk. There are a whole bunch of other lessons that you learn as a programmer, but those two are the main ones. And when you apply them across the board to something that you're developing that's brand new, it can take you into some interesting places, some places that you never thought of before. And what starts out as something simple and straightforward that you thought was going to take a day or two ends up being incredibly complex. It takes 10 years. And when you get done, you have something that will literally, I think, change the world. And that's what Frognet is. So Frognet started out as a simple need to do a streaming network. And I did that. I stood up the little streaming network and I hooked it up to the internet, and I was able to have my little television station in a suitcase and carry it around and set up wherever I want, and that was awesome. Then I figured out that I could hook those networks together, right? I can make an internet of Frognets, and then I figured out that I could make them work over long distances, and I can make them work with low speed, and I can make them work with by coming together and joining and self healing, and by splitting apart and becoming independent units, right? And having it all be automated, fully automated. So there's nothing that the user has to do. It just happens, right? But that wasn't the end, right? Because to do that, I needed to do this thing we called semantic compression, which was a way to make the messages smaller. And that led me down a pathway that ended up introducing to me the concept of network addressable shared memory and making it work, right? So what we have with Frognet, if you just have a single network, you have a shared memory ability that extends to every single node on your network. So all 254 of the nodes that are attached to your network have now got a single shared memory state. And think about that, right? No more sending messages back and forth. Frognet's motto is memory, not messages. And that's it. You're writing stuff into memory. You're addressing it as if it were memory, not sending, send, wait, receive, messages back and forth that you have to write handlers for and you have to write protocols for, and that are seriously the most dangerous part of this kind of programming. And there's an analogy for this too. This is something that happened before when we went from assembler to C. There were people out there, lots of people, who could write very, very efficient assembler, but there were lots more who didn't want to, and they wanted to write in a higher level language. They still had contributions they could make, but they wanted to write in a higher level language, and that's where C came from. And that's what Frognet is. Frognet is C to Rest's assembler. It is the next evolution, and it gives you statefulness, and it gives you shared memory, and it gives you timeliness, and it gives you all of that across the internet. And just to sort of whet your appetite a little bit, I'm going to show you a couple of things right now that that we're going to get into much later. This is the existing network. This is the network that I have running right now. It's got nodes in Seattle and in New York, and BA means Big Apple, so Seattle and New York. And these are the network pathways between them. So every node has a connection to every other node on the network. And I can prove that with the FrogNet monitor. These are 4 different machines. You can see Seattle 2, Seattle 3, Seattle 5, and Seattle 6. And on each machine, I have the list. This is an active monitor of every other machine in the network. And from here, I can come down and I can say, for example, what are the sensors that you have on you? And for the sensors, some of them are going to be soft sensors like System Perf, which is going to give me the disk I/O speed and things like that, right? Memory, all that kind of stuff. And some of them are going to potentially be physical sensors like the GPS location. This tells me where we are, right? And this information, all of this information is available across the network in real time to all of the nodes on the network. So this is network shared memory, and this is where FrogNet has come. And this is where we invite you to join us. This is the first in a series of videos that will describe FrogNet shared memory and describe how to use the FrogNet system. The first 4 or 5 are going to describe how to install FrogNet, get it configured, get the broker configured, and get yourself set up so that you can replicate what we did with the FrogNet communicator in getting a transcontinental call in at 850 kbps. And I'll tell you right now, 850 kbps is high. You're going to be able to do that at 450 kbps and maybe lower. Might not be at 720p, but it'll be there. The system is extremely resilient. So the first set of videos will get you to the point where you can bring it up and use the FrogNet monitor or the FrogNet communicator to talk amongst themselves. And then the second set, there is going to be another set that goes into more in depth in into the proprietary technologies that are inside FrogNet, semantic compression, the FireWire, the FrogNet wire protocol, and things like that. So choose your path and hang on, because this is a paradigm shift unlike any you've gone through since we went from assembler to C. Welcome aboard. All right, have fun.